Hi guys. This section is going to be a little long, so I'm going to kind of talk till the video's at about 15 minutes, and then I'll start a new video. If you, you need to follow along with me on page 129. I understand that it's kind of hard to watch the video and kind of follow along in the book, so maybe you could either print the page or take a screenshot of the page and put it on your phone. Or even just kind of check it out, read it through it, and then come back to the video and just make sure you understand what the prompt is. Okay, so again, I'm on page 129, and we can label our notes. This is 4.3, and this is proportional relationships. So I know we've been talking about proportional relationships, but we are going to add today graphs and graphs. So realize we started teaching you proportional relationships specifically to build up to this, to build up to understanding it with graphs. So think of this as kind of pulling everything together. This is the bigger picture of why we do proportional relationships and what they look like. Okay, so the first thing I want to remind you is every time we have an equation, so we've been working with like maybe a y equals 5x, or anytime you have a table like this with x and y, what you really have is a graph, okay? Let's not forget everything we're doing is a graph, okay? And if you know the variables, what x and y mean, you can put those on the graph. And so we're going to take this data and take these relationships we're looking at and see it on a graph and understand the real life application of these numbers. All right, so some of this is stuff we talked about last week, so just kind of bear with me. So we are graphing proportional relationships. The form we're looking for is y equals kx. So let's kind of remember what each of these variables mean. Now, k is going to be replaced with a number. So k is our constant. And it's constant because I'm multiplying by all the x's. Because when I write k and x next to each other, I really have a multiplication problem. So what I do is I take all my x's, okay, and x is time. So let's say I have 1, 2, 3, 7, 10, and the k tells me what I multiply the x by to get the y. So x is almost always time, and y is going to be your total. Okay, it could be total money, total hours, total gallons, total whatever the total is. And so in this case, we're going to make y, water used. And the unit on this is gallons. Okay, so if they tell us that k is 5, that means every x we're going to multiply by 5 to get the y. So 1 times 5, 2 times 5, 3 times 5, 7 times 5, 10 times 5. Okay? And so if they gave us this without this, to find out what the k is, we would ask ourselves, what did I do to the x to get the y? And you want to go through the numbers. What do I do to 1 to get 5? Okay, times 5. What do I do to 2 to get 10? Oh, 5 times 5. 5's my constant. Okay? Now, we know this is proportional. Right now, what I've taught you so far, and then I'm going to teach you one other way to check, but right now, we know this is proportional because when I do y's over x's, now remember we talked about that, y's over x's. When I do y's over x's, I get the same number. So 5 divided by 1 is 5. 10 divided by 2 is 5. 15 divided by 3 is 5. So you can divide to get your k. You can ask yourself, what did I do to x to get y to get your k? And then you can check if it's a proportional relationship by dividing y's over x's, y's over x's. Remember, the top number, if you were using a calculator, would go in the calculator first. If you were using long division, that top number goes underneath. Okay? All right. So, let's kind of talk about the problem. We're going to kind of work backwards. So here's the problem. The equation y equals 5x. So y equals 5x. The equation y equals 5x represents the relationship between the number of gallons of water used, y, and the number of minutes, x. Okay, for most shower heads manufactured before 1994. So when we're on page 129 and we're looking at letter A, explain why the relationship is proportional. How does the equation represent the constant of proportionality? Okay, so let's add those words. Of course, my board is filled, but let's add, you add the words wherever it makes sense for you. This is also called constant of proportionality. Okay, because it's the constant that we multiply the x by to make this whole situation proportional. Okay, so k equals 5, and that means 5 gallons per 1 minute. And that's what we need for the k. We need that unit rate. We need the 1. We don't want to know how many gallons in 10 minutes. We want to know how many gallons in 1 minute. And then something I've been telling the students that I think has been helping is when I say gallons per minute, that tells me the order I need to divide in. Gallons divided by minutes. If I said miles per hour, that tells me the order I need to divide in. Miles per hour. So if you can make what I've been calling a per statement, because I wouldn't say hours per mile. That sounds funny, and I know that's not right. Okay, so you got to make that per statement to help yourself decide what order to divide in. If you knew which was y or x, you divide y's over x's. If you know which one's time, x, then you divide by time. Gallons per hour, miles per hour. We always divide by the time. Okay, price per ounce. So you would do a price divided by ounce. So hopefully you're kind of seeing a connection between bringing down that unit rate and knowing the k and writing the equation. All right, so if you're following along on page 129, we're going to do letter B and complete the table, which we kind of, like I said, we're working backwards, so you can fill that in on your paper. And then what they have us do, and now fill this in if you need to because I'm about to erase it. Now what they have us do is take that table and write it as ordered pairs. Ordered pairs. So I'm going to write ordered pairs. Remember, if I write, you write. Okay, so we had 1, 5. In 1 minute, I have 5 gallons. Then we had 2, 10, 3, 15, 7, 35, and 10, 50. Okay, so we wrote our data in ordered pairs. Let's go on to letter D. I want you to plot your data. Okay, plot your data. Pause the video, plot your data. When you come back on, I'm going to hold this answer sheet up so you can see it, because if I put it up on my board, it's not as accurate. So pause. All right. Here's what it looks like. Please make sure that yours looks like that. Okay? All right, let's move on to letter E. So letter E says, if the showered head is used for 0 minutes, how many gallons of water will be used? What ordered pair represents the situation? What is this location called? So if I have been going for 0 minutes, I have 0 gallons. Okay, so that means 0 gallons. That's also 0, 0, and that place is, and make sure you write this down because you're going to need this, that place is called the origin. Okay, don't get to 8th grade and have your teacher say, what's 0, 0? And you say, I don't know, the center, the middle, the origin. Okay, kind of where you start, because think about it. Every time you graph something, you come back to the center to count out your x and your y. You come back to the center, 1 and 5. 2 and 10, back to the center, 3 and 15. Okay, so we call it the origin because it's our first place. It's where we start. Letter F. If the shower head is used for 1 minute, how many gallons of water will be used? What ordered pair represents the situation? Okay, so 1 minute, because we know X means time, and X comes first in an ordered pair. So I know 1 minute, 5 gallons. So 5 gallons per minute. And the data point that represents that is this one. If you said how many per 2 minutes, this data point. Okay? But this is also called our unit rate. Please make sure you add that to letter F. Letter G, draw conclusions. If you continued the table to include 23 minutes, would point 23, 125 be on this graph? Why or why not? So let's look at that dot and talk about this. So if I had 23 minutes, well, what did we do to our X to get our Y? We did times 5. So 23 times 5, 15, 10 is 115. And the point they gave us is 125. Okay, so in 23 minutes, do we have 125? No, we only had 115. So the answer is no, this point is not on this graph. Okay, so hopefully you made some connections. Make sure you fill out the Explore activity on page 129 and bring that to your next EA meeting. And I am going to stop this video and get started on the next one where we're going to kind of keep looking through this and look at some more examples. Okay, thanks guys.